I'm Sanzida, and this is our paper titled Communication, Collaboration, and Coordination in a Co-located Shared Augmented Reality Game Perspectives from Deaf and Hard of Hearing People. A co-located collaborative shared AR environment would be such an AR environment where multiple players will be placed in a singular physical environment where they'll have the similar view and control over the virtual objects. They can interact with each other and with the objects along with the control to manipulate the virtual objects in real time. This kind of AR has raised research interest in AR technology for a long time. However, to date, there is scarcity of research focusing on whether collocated collaborative shared AR or CSAR environments can facilitate communication and collaboration while being similarly engaging among linguistic minority groups such as deaf and hard of hearing or DHH people. If we look at our current literature, we have three domains of studies. First category is prior works that focus on users' behavior in collaborative, co-located, and shared AR environments, but did not include DHH participants. Second domain is about DHH users in shared spaces, which reveals the challenges, innovations, requirement, and potential for inclusive interaction. However, it lacks exploration of co-located collaborative AR environments with users with mixed hearing ability. The work regarding AR technologies and DHS users are there at the third category, but these only focused on design accuracy, implementation, and users' interaction with the technology, which only point towards our lack of knowledge regarding communication, collaboration, and coordination behavior of DHS users within these environments. Addressing this research gap is important as it can further be used to make these environments more inclusive and diverse for everyone. The key contribution of our work are providing an initial exploration of communication dynamics among DHS users in co-located CSAR environments through a user study. We specifically explored how DHS participants leverage multimodal communication by blending verbal and nonverbal cues based on each other's needs and capabilities. The interrelationship between communication and collaboration with increased communication fostering enhanced collaboration among DHS participants, coordination strategies DHS participants employ to overcome challenges and enhance gameplay over time, providing design implications such as auto-generated speech-to-text transcription and customizable visual information grounded in DHS participants' experience and suggestions for improving communication accessibility in co-located CSAR games. Our research was divided into two major segments, collecting data and analyzing data. Data collection phase had user study and semi-structured interview. We recruited participants based on a questionnaire and later the gameplay took place where we took note of our observation. In a separate time, a semi-structured interview were conducted over online where we initially constructed the questions based on the AR game. However, the semi-structured nature of the interview provided us with plenty of scope to improvise our questions. Later, we analyzed the data that we gathered qualitative data from the questionnaire before recruiting participants, observational data from the gameplay, and qualitative data from the interviews. So the user study took place with 17 DHH people with varying levels of hearing abilities. Here we utilized codename Urban Legends, which is a multiplayer AR game probe where the game takes place in a co-located collaborative environment. Our study was divided into two major segments, data collection and data analysis, as I already mentioned. In the first phase, we conducted the gameplay and the players were divided into 7 groups and played 5 rounds of game in total. The first 2 rounds took place in a private area and the last 3 rounds took place in a public area. The one-on-one interview took place after the game, and which was the major source of our qualitative data. The first thing was the findings was co-located collaborative AR environment could foster social interaction among the players and more explicitly verbal and nonverbal communication. As nonverbal communication, they lean towards hand gestures and body language which were not appropriate sign languages. Furthermore, nonverbal communication played a positive and effective role in fostering communication. We also found that communication dictated the amount of collaboration. For example, we observed most communication took place before the game started in prior rounds, and most of the collaboration took place at that time. Players enjoyed the collaboration in the game and called it the best aspects of the game. Players' coordination behavior could be divided into three categories, which were with air components, with surroundings, and with other players. Players faced a few technical difficulties, which further hampered their gaming experience. However, they were able to overcome the challenges through communication. Few of the design implications that stood out were CSAR environments should support multimodal communication, prioritizing customizable visual information. These kinds of environments should also simplify coordination and raise awareness. Some of the limitation of our study were that our participants were grouped based on their availability, and majority of them preferred verbal communication. Additionally, due to the game's nature, participants could play and win the game with relatively minimal communication. For the future research, we aim to choose different AR environments and conduct multiple studies where we will recruit participants from diverse backgrounds. This is crucial to understand more environment-specific challenges and ways to overcome them. Our study can potentially spark new avenues of exploration within the field of HCI, which can further reveal prospects of to utilize more complex multimodal communication strategies among DHH participants. Thank you for listening.